Hi. We had to split this chapter 3 into two parts. Voltage versus for the ES70S 1/16 inch diameter electrode carbon dioxide shield metal gas. Ranges from 0 to 500 in volts, voltage amps 0 to 500, voltage from 0 to 35, short circuit transfer region, repelled transfer region, protective transfer region. Alright, your voltage versus the E70S3 1/16 diameter electrode shield metal argon with 2% oxygen addition. Current amperes 0 to 500. Voltages from 0 to 35. Unusable short circuit transfer region, globular transfer region, spray transfer region. Alright, versus the voltage E70S3 1/16 diameter electrode carbon dioxide shield gas 0 to 500 amperes, 0 to 35 volts. Your range is from short circuit transfer region, repelled transfer region, projected transfer region. Voltage current with the ES74 1/16 inch diameter electrode carbon dioxide shield gas. Current amperes 0 to 500, voltage 0 to 35, short circuit rate transfer region, repelled transfer region, projected transfer region. Alright, voltage versus the E76 1/16 diameter electrode carbon dioxide shield gas 0 to 500 amperes, 0 to 35 volts, short circuit transfer region, repelled transfer region, projected transfer region. Alright, your voltage versus the E11OS 1/16 inch diameter electrode shield gas argon with 2% oxygen additives. 0 to 500 current amperes, 0 to 35 volts, global transfer region, spray transfer region. Alright, the manual welding guns have been designed. All the manual guns have the nozzle directing shield gas around with the arc over the welded puddle. The filler wire passes through the copper contact tube in the gun where it picks up the welding current. Some of the metal welding guns contain the wire-driven mechanism with the gun itself. Other guns require a wire-feeding mechanism be located at the spool of the wire, which is in some distance for the gun. In this case, the wire is driven through a flexible conduit with the welding gun. The manual gun design combines the feeding mechanism with the gun and the wire itself. The argon in the shielding gas used most often. Small amounts of oxygen, 2 to 5% frequently, are added. The shielded gas is welded, stabilize the arc, and provides a better wetting action, producing a more uniform welded bead, reducing the undercut of the carbon dioxide used with the shielded gas because of the cheaper than argon and argon oxygen mixtures. The electrode designed to be used for the carbon dioxide shield gas required with the extra deoxidizer and the formulation because of the heat of the arc and the carbon dioxide associates the carbon monoxide and oxygen, which causes an oxidation of the welding metal. 5. Welding parameters. Figure 312 through 318 show the relationship between the voltage and current level of the type of the transfer across the arcs. Pulse current of the gas metal arc welding process and advantages. The process is useful when low and high heat input. When one of the working with the metal doing the out position welding, for example, the lower heat input range of the pulse current has the advantage of the continuous projected spray transfer process. The high quality with welds can be produced in mild, low alloy steels. In the welding, aluminum large diameter wires can be used welded with less porosity and produced because of the less hydrogen and oxygen becomes the wire surface. Alright, your disadvantage, the major disadvantage of this is because of the complex power supply and the addition of the gas melting arc welding wire feeder and welding torch. Process principles. Pulse gas metal arc welding is in the modification of the process you obtain with the spray transfer with the average current level of the globular transfer. There are the process provided with a higher ratio of heat input with the metal, the disposition rate with the short circuit with the pulse gas metal arc welding operates the heat inputs in between the use of the spray and the transfer with the short circuit transfer with some overlapping range in the process. The current is pulled back and forth between the projected transfer with the gravitational transfer range with electronically switching the current level back and forth from them. In figure 319 shows the current output waveform. The metal transfer sequence in the pulse current with the welding is known as also has the trade name as pulse arc. All right, for equipment of the poor supply with the pulse current equipment combined with the three-phase full wave, the transfer form rectifier power supply as in a single-phase half-wave pulse unit. These units are connected in parallel. The electronically switched in the operation to give output waveform in this figure shown 319. Standard gas metal arc welding wire feeder torches are used in the process. Short circuiting will transfer the gas metal arc welding advantages. The short-circuiting process is widely used for the current welding and then materials up to 1/4 of an inch in all position and causes a little distortion, few metal arc defects. The process is used with the carbon low alloy steel less often than stainless steel, aluminum, and also used with the out position welded with the thicker material. Disadvantage is generally welds made with the short-circuiting process with a slightly more than quality than produced with the spray transfer method. They may not cause trouble or high-quality welds are not required. Process the principle of short-circuiting transfer regular variation of the gas metal arc welding process and generally similar. Spray transfer welding, the main difference in the way the molten metal the transfer for the end of the electrode wire with the metal welded puddle, and spray transfer the welding to droplets are transferred through the arc. With the short-circuiting process, metal transfers occur during the repetitive short circuits caused with the molten metal with the electrode contacts with the welded puddle. The welded current is well below the transition level required for the spray. Alright, figure 319 shows the outlet current wave with a fully form of a pulse current power supply with the metal transfer sequence as shown. Alright, you have your current, your time versus which your current runs with a pulse current, peak current down to a background current with pulse air transition currents 1, 2, 3, 4, and 5. Above the line, above your pulse peak, when your pulse peak current, you have a projected transfer current range on your bottom background current. You have a gravitational transfer current range. Alright, as the end of the filler wire metal is formed with at a ball, figure 320, but it becomes a larger unit with the touch of the welded puddle extinguishing the arc, creating the short circuit of the arc length with the deliberately kept in so that the metal ball touches the puddle before it separates for the end of the filler wire. When the short circuit occurs, the welding current increases rapidly, causing the drop of the molten metal to be pinched from the end of the filler wire. This reinitiated with the process repeated. The short circuiting action is rapidly as many as 200 short circuits per second and may occur. This process is also known as short arc dip transfer or fine wire welding. For equipment short-circuiting transfer welding, it is used with the same the constant voltage of equipment such as it does spray transfer. The power source must have the device inside the variable, but control the amount of the inducing electrical current circuit with the inductance control of the rate of the current with increase when the short occurs with the permit the arc to restart without welding splatter. A short-circuiting welding requires a small diameter filler wire of 3/100 of an inch diameter. For example, this generally used with the spray transfer the welding. The shield gas used with the short-circuiting welding depends on the metal being welded. Argon, helium, a mixture of these arcs are used in the welding. Aluminum, carbon dioxide, mixture of the carbon dioxide, argon with a small oxygen addition used for welding mildly low alloy steels. For stainless steel, argon with the oxygen and carbon dioxide addition is used. 3.5 Flux core arc welding, or FCAW. Flux core tubular electrode welding has evolved from the gas metal arc welding process to improve the arc action, metal transfer welding, metal materials welding appearance. Advantages: the more advantage of the flux core welding are reduced with the cost of the higher disposition rates for the shielded metal arc welding and the solid wire gas metal arc welding. These costs the loss of flux core electrode because of the alloy agents are in the flux, not in the steel filler wire as they are with a solid electrode. Flux core welding is ideal with a bedded appearance and is important. No machining of the welding is required. Flexible core welding without carbon dioxide shield can be used with the most mild steel construction applications, resulting in the welding have higher strength and less ductility than those with carbon dioxide shield are used, where there is less porosity, greater than penetration of the welded carbon dioxide shielding. The flux core process has increased tolerance for the scale and dirt. These less welded spattered than the solid wire gas metal arc welding. Are your disadvantages? Most low alloy mid-mild steel electrodes flux core type are more sensitive to change of the welding conditions than shield metal arc welding electrodes. The sensitivity called voltage tolerance can be decreased with the shielding gas is used if the slag forming components of the core material are increased. The constant potential power source and the constant speed of the electrode feeder are needed to maintain a constant voltage. Alright, C. The process of principle of the flex core welding wired electrode hollow tube filled with a mixture of the deoxidizing flexing agents, metal powers, and ferroalloys as shown in figure 321. The closure of the seam will appear with the fine line is only visible. Alright, figure 30 shows steps in short-circuiting metal transfer 1, 2, 3, 4, 5, 6, 7, 8, and 9 electrode filler wire arc. The difference between flux cord wire and solid cold drawn wire. The flux cord electrode welding can be done in two ways. Carbon dioxide gas can be used with the flux to provide with additional shielding, or the flux core alone provided with all the shielding gas and slagging materials. The carbon dioxide gas shield produced with a deeply penetrating arc usually provides better than is possible without external gas shield. All right, D, your equipment. The equipment controls for the flex core process are similar and sometimes the same as the used with the straight transfer method. The unit consists of the constant speed wire-driven system, water, air-cooled welding torch, and a constant potential of DC unit within 100% of the duty cycle. 3.6. Gas tunks arc welding. Gas and tunks arc welding process on consumable electrode with the inert shielding gas. The process is also known as tungsten inert gas, or TIG. By trade name, the heli-arc or the gas tungsten arc welding is similar with the arc welding process in that the heat is generated with an arc between the non-consumable electrode by the workpiece. The equipment and the electrode type that distinguish the gas tungsten arc welding from other arc welding processes. Advantages: the gas tungsten arc welding process is the most popular method of welding aluminum, steel, stainless steel, and nickel-based alloys. It produces the top quality welds at almost all metals and alloys in the industry, and the process provides the most concise control of the welding any other electro arc welding method because of the heat in the filler metal. The independently controlled visibility is excellent because no smoke or fumes are produced during welding. There is no slag splatter that may be cleaned between passes or completed with the weld. Gas tungsten arc welding is usually considered one of the most versatile processes because it produces high quality welds in any position configuration. The final major advantage is reducing distortion while the joint because of the concentrated heat source. This is one of the best precautions that can be taken to prevent the welding cracking and lockup and stress. Disadvantage: the gas tungsten arc welding process is expensive because the arc travel speed of the welding metal depositing rates are lower than with some of the other methods. In addition, with less advantage, you use the gas tungsten arc welding in heavy, thick materials. Our process principle of the gas tungsten arc welding process: the tungsten alloy electrode mounted with a special electrode holder designed to furnish the flow of the inert gas around the electrode and the arc. The arc is these shows the cross-section of flux cord wires. The cross-sectional flux cord wires, the circle with the indent, blah. Alright, struck between the base and the metal and the electrode. One of the two methods of the first is called the scratch start, with the operator actually touched with the workpiece with the tungsten and withdraw slightly. This section method usually has high frequency discharge from the electrode of the workpiece will establish the arc. The better with the wheel to have the very clean and scratch starch could leave the particle of the tungsten in the weld, causing a brittle size after the arc is started. The filler metal is required and fed with the welding pool near the arc, is shown in figure 322. The molten welded metal seal adjacent to the base metal with the electrodes are projected with the flowing of the gas envelope and air gas, generally argon helium mixture of the two. Most of the gas tungsten arc welding is done manually for the production of an assembly type of the weld, such as long butt of the welds and system can be entirely automated. The AC is used generally for aluminum, magnesium, while the DC is straight. Polarity is used for all other metals. The equipment includes the electrical power source, electrical holder, torch, tungsten, and tungsten alloy electrodes, gas flow regulating equipment, usually the remote rheostat or off-on switch of the control current control. There are AC and DC power units built-in with the frequency generator designated specifically for the gas tungsten arc welding. These automatically control the gas and water flow with the welding begins and ends with the power supply. Without these controls are also can be used. Alright, 2. If the electrode holder, the torch, is the water cooled and supplied with the cooling of the water is needed for the electrode holder that are made with the electrodes and the gas nozzle that can be readily changed in either direction size of the replacement. 3. Mechanically gas tungsten arc welding equipment may include the electronic devices checking and adjusting the welding torch equipment for the working handle, the provision of the inhaling of the arc, controlling gas workflow, filler metal feed mechanism. 3.7. Submerged arc welding. In this process, submerged arc welding process, the arc is not visible with the submerged under the layer of the granulated flux. See figure 3023. The process can also be used either with a single electrode wire, as many as American Welding Society D11 described the procedure, equipment, electrodes, and flux used within submerged arc welding. Advantages: submerged arc welding is an efficient process that can be used nearly in all ferrous metals welded with a very good quality, producing a wide range of metal thickness thicker than 1/16 of an inch carbon alloy or stainless steel with 1/2 inch thickness welded in one pass, while thicker materials require more passes. Welded metal deposition and arc travel speeds, weld completion rates for the better than those of the other process. There is no visible arc when the weld is better than done. Deep penetration effect for the concentrated heat allows the narrow the welding groove. This takes effect less than filler metal to make the joint with submerged arc welding than the other welding process. The unfused flux can be recovered and recycled when the welding is finished. Disadvantage: the basic elimination of the submerged arc welding, that is, it only can be used with a flat position for the horizontal fillet welds. Welds can be made in the horizontal position, but are similar since the gradual flux needed with the shield to welded metal must be in place. The front of the electrode are complicated with the jams, and supports may be required to contain the flux. The equipment used for the process can be handheld with using the mechanism, making it high and cumbersome, therefore limiting it as fraction in the shop. Fusible flux must be removed by chipping in the wire brushing. Alright, process principles. The submerged arc welding places the benefit of the flux without the spark and the spatter. The smoke and the flash electrode and the welding pool are completely covered at all times during the weld. The flux makes all three special operating conditions which distinguish the submerged arc welding from the other process. When the colder flux does not conduct electricity, therefore the welder must establish the conductive path at the starting of the arc. This can be done in scratching start when the electrode touches the base plate and preparing some of the steel wool and the flux as a starting point. In the molten state, flux becomes the highly conductive. Only the arc started with the heat produced for the current scales for the surrounding flux to become molten. This forms a conductive path which is kept with the molten continued flow of the welding current. With the buried pool of the flux is metal, very visible part of it remains unchanged for both appearance for the properties and can be also reused. All currents and polarities are used to bring on the desired penetration. The bead shape of the reverse polarity provides the best bead shape, present penetration, while straight polarity gives the higher disposition rates, but less penetration. Alteration current provides for the penetration somewhere between the two, and there it's preferred with the multi-wire welding. The fused flux is shipped off the welding and discarded. The welding electrodes must be positioned properly. Flux is in front of around the electrode by the hopper. The arc is struck and the electrode moved along the weld. The operator watches the ammeter, the voltmeter readings to control the current voltage adjustment. The variable speed motor controls electric feed, and a power operated carriage controls the travel unit. Unused flux is fed with the back into the hopper. Alright, here you have let's back out of this. This is your figure 322 gas tungsten arc welding process. Your gas supply, your welding machine going into the gas line, and also the power lead with a handle and electrical cooling, water lines in and out, electrical holder, tungsten electrode, electrical conductor with gas passages. Handle, power lead, electrical conductor, gas shield, insulating shield, sheath, shield of gas existing past electrode, ground connection attached to the work filler rod. 322 submerged arc welding. Here is the flux feed tube, the base metal, the electrical wire, molten slag, solidified welding material, molten weld, arc path. Alright, 2, moderately thick section of the material up to 1 inch, but the carbon content up to 0.35% can be welded without precaution, such as preheating in the post-welded heat treatment. The preheating with the generally needed for the carbon content of 0.35%. Low alloy steels may be welded if the welded area is preheated with a slow rate of cooling. This must be done avoiding cracking the welding heating in affected zone. When certain to quench for the temperature structural steel, the American Society Testing Materials A5514 14 and A5617 are welded, heated up into the closing controls to make these such sure the strength and the nut toughness are retained in the heat affected zone. To keep the high level of the strength and notch toughness, the heat must be dissipated rapidly, and the desirable microstructure form any other thing that delays cooling, such as preheating of the high weld and heat inputs, should be avoided. D. Equipment. Both semi-automatic, automatic submerged arc welding equipment is available. The types used generally depends on the work to be done. The economical factor: semi-automatic equipment is better for the repair welding, for welding that cannot be done automatically because of the geometry of the part. In Figure 324 shows the equipment needed for the automatic submerged arc welding, including the power source of the wire feeding system, the flux feeding of the system, and the welding torch. 1. The power supply made with a DC current, constant current with a DC constant voltage or alternating current. The power supply with the wire-driven mechanism must be designed to operate together so that the arc length can be controlled effectively. With the submerged arc welding, generally is done with a higher currents of 500 to 1,000 amperes than other types of arc welding. Some of the power supply must have the high current rating at a high duty cycles. Alright, Figure 324 shows the automatic submerged arc welding equipment controls for the automatic welding in flat position. Your workpiece, you ground to the workpiece, going to the power slide to the controls, while the controls go straight through the wire driving mechanism to the wire supply on the wire guide, current pickup gun, and the flux hopper. Alright, the electrode using the submerged arc welding gas, generally with the bare rods with the wire and fuel coil. The choice of the electrode depends on the way of the alloying the elements of the introduced the weld. Once the method is used to melt steel electrode, flux contains the alloy. Another method of only often used with the special alloy steel electrodes. Neutral flux includes low carbon steels, low carbon alloy steels, special alloy steels, high carbon steel, stainless steel, non-ferrous alloys. Fluxes are granulated, fusible mineral materials and various composition particle sizes. The choice of the flux depends on the welding process, joint configuration, composition of the base metals of the weld, and flux may include the aluminum elements. 3. Exothermic welding. Exothermic welding is heat generated by a chemical reaction between a combination of aluminum and iron oxide. The mixture is placed with the hopper above the mold which surrounds the joint and is then ignited. The chemical reaction occurs. The molten metal in the slag drops off through the hopper, and since the molten metal is heavier than the slag, it settles at the bottom of the mold and touches the steel joint. The molten metal, the surface of the metal diffuses with it, and forming the weld. This process is commonly referred to as thermite welding. It is used in joint referencing, reinforcing rods, rails, large casting, forging. For preparing large structural shapes, historical thermite welding was large confined with the structural made of iron and steel. Recently, the substitution of copper oxide and iron oxide has led to many applications with electrical industry, such as joining, repairing electrical connectors, cables, bus bars, bus tubes. Thermite welding is used with the welding pipe in the application. Thermite does not mix with the pipe metal when it merely furnishes the heat of the metal into the pipe end, which are then butted together as metal. Advantages. 1. The welder needs very little instruction experience to produce a good weld rapidly. 2. The large section may be fusible and welded into large quantities of filler metal may be deposited quickly. Thermite welding can be roughly compared to the founding recasting operation, with one difference in the metal between the poured is considerably hotter than the melted in furnace. The complete weld left in the mold cools and slowly reducing residual stress. Are the disadvantages. Molds are needed to hold the molten metals around with the welded joint from one of the kind of jobs, such as repairs. The molds must be constructed individually. Suitable wax or plastic from filler metals and must be inserted with the gaps to ensure the proper clearance between the parts preferred. With the permanent molds are used with the repetitive projects. Welding rails and reinforced rods are, for example. Process principle. Thermite welding is based on the fundamental principle that aluminum is more chemically active than iron. The welding process consists of the mixing of iron oxide with aluminum, both the powder form, and producing them in the hopper or crucible above the mold with it surrounded with the joint area. The joint of the weld must be cleaned with the properly spaced with preheated with ignition powder, such as the mixture of the barium peroxide. Aluminum powder is based on the top of the thermite and fuse is inserted with the powder, and the reaction starts after. Fuse ignites the mixture that happens with about 2,000 degrees Fahrenheit. The reaction non-explosive takes about 30 seconds. Once the mixture starts to burn itself, propagating with the reaction to complete with the molten metal that has reached with the temperature of the approximately 4,500 degrees, which is nearly 1,600 degrees higher than the temperature ordinarily molten steel. The metal is produced with the molten for the form of the weld. The molten metal allowed with the remaining of the positive position several hours of the permanent solidification enabled with the weld to deposit the metal cools and uniformly comparatively free of the stress. The mold of the removed of the gates and the riser are cut away with specific welds can be grounded with the machine, although the principal application of the thermite welding has been with the aluminum and iron oxide mixture with the steel structure. Other metals and their oxides may be included with the thermite mixture. The chromium, nickel, magnesium, tungsten, titanium, moly, pendium, cobalt can be used Alright, thermite welding crucible mold. Alright, you have your changing magnetic iron oxide Fe30 oxygen 4 aluminum powder, line crucible, magnetic thimble tapping pin, magnetic stone. Then we move on to the path of the molten thermite into the pour gate of the mold of the thermite weld, the plug iron stand and core, the heating gate, and the space of the thermite weld with the section to be welded, riser and basin for slag. Elements, alloys, and iron. These elements, alloys, and irons are used with a higher strength, ductility, and hardness than required. They also permit control with the temperature and time of the reaction. Cast iron can be welded with a special thermite mixture. Equipment. The thermite welding kits are available that consist of the permanent mold of the prepackaged thermite chains, consumable tapping discharges with the ignition powder of the fuse of the individual constructed molded requires wax of the foam filler and such mold with a special mixture with the silica and sand and plastic clay and gate risers, pouring gates, and slag basin. Figure 325. 3.9. Arc stud welding. Arc stud welding is an arc welding process in which the electric arc is stuck between the metal and stud and another piece of metal, which the surface is to be joined with the properly heated. They are brought together under pressure. The ceramic ferrule surrounding the stud provided with the particular partial shielding, with the process generally referred to as stud welding. American Weld Society D1. One describes the welding procedure, equipment, workmanship, quality control, and inspection requirements. Advantages. Arc stud welding has many advantages and uses where the process is needed to be drilled with the punch holes nor the fastening the object mechanisms and mechanically to maintain structure with the bolt and rivet to the screws. The arc stud welding is welded acceptably in the metal work industry, such as virtually every other phase of the operation automatic. No previous welding experience is necessary, and experienced operators can be trained quickly, and once the equipment is set with a particular job, high quality welds are easily made with the welding gun. Alright, figure 326 shows the steps in stud welding operation. A. The gun was properly positioned with the stud welding. B. The trigger is depressed, the stud is lifted and created arc. C. The arc period is completed and stud is plunged into the molten pool of metal on the base form. D. The gun is withdrawn, the stud is removed from the ferrule, and ferrule is removed. This is stud welding equipment. You have your workpiece, your ground cable, tooling to the timing device, and power supply. Your power supply then goes into the electrical cable, pressurely manually applied to the control trigger with the stud welding gun and the ceramic ferrule on the studs and the workpiece. Light is easy and handled to make the equipment very portable. Disadvantages. This is a versatile process. There are no disadvantages. However, there are some limitations on its use. Stud welding is approved for the use of low-pressure heating boilers under the American Society of Mechanical Engineers boil pressure vessel codes for all the applications existing. Say bolts. These include the cover and clean out excess doors, studded openings of the boiler tube, water heater coil. Stud welding is approved for the use of the non-pressure on power boilers and unfired vessels. Alright, process and principles in the arc stud welding process. If the flux coat of the stud is inserted with the cola with the chuck with the integral part of the gun, the porcelain ferrule surrounds each of the stud with the shield of the arc and holding the molten pool within place with the help then from the acceptable filler shape. The flux on this end of the stud helps the operator to control the arc and make the stud welds in position. The operating places of the gun in proper position, the pressure of the gun holds of the stud against the workpiece. When the trigger is depressed, the complete with the electrical circuit, causing the collet to withdraw with the stud with the working piece of the proper distance created with the gap in electric arc. In addition, with the automatically timed interval, the motion end of the stud with the prolonged with the motion pull, which is formed with the surface of the plate with the process is similar with the conventional metal arc welding. In effect, for the stud serves as consumable arc and weld it while it is flowing. Molten metal quickly solidifies the collet, releases the stud. The operator removes the gun and ready the next welding operation within seconds. Stainless steel mechanism aluminum can be welded with basically the same equipment they use for the steel, except for the inert gas must be fed through the gun to protect the weld. In the practice, the same restriction applied with the both metal arc welding of the carbon steel for the seals and stud welding. The carbon seals with the carbon content up to 0.3 tenths of the percent may be welded without the preheating when the carbon steel exceeds the 3 tenths of the percent. Particular heavy section preheating is advisable to prevent checking of the heat effective zone. In some cases, the combination of preheating and the post heating has proven helpful. Two low alloy steels may be satisfactorily studded with welds without preheating with the carbon is held to 1500 of the percent mechanisms to prevent cracking for the heated effective zone. Preheating is necessary of the carbon content of 1500 of the percent. The high treatable with high strength low alloy structural steels require more tension since they usually harden enough to form the martensite heat and effective zone. These steels are quite sensitive in the underbead cracking of the welding area is usually low in ductility. Preheating is about 700 degrees Fahrenheit recommended with the steels in the category are studs welded. The equipment of the stud welding consists of a DC power supply with stud welded gun, welding cable to ferrules of the shield of the arc, and the controls, including the time device. The equipment is usually portable with the stationary equipment with the large scale operations usually used widely. When the power supply normal, the welding of the machine adapted with the stud with the welding, the cable is made with the same with the storm inner welding cable. The gun is designed to ensure the correct alignment. Hold the stud. The gun is the trigger to start with the current flow with the timing device for the draw of the stud at the proper time to create the arc and move the stud into the molten pool. Holds it until the molten pool solidifies. Figure 327. A ferrule rule is used. A ferrule used with each stud is shields arc with the protective welders eliminates that. The need for the full face helmet. The ferrule concentrates the heat during the weld, confines the molten metal to the welded area to help prevent the bolt oxidation of the molten metal during the arc cycling and the chamfering of the workpiece. Studs are available to variety of shapes, sizes, and diameters. Some of the design of the threading and the riveting, and others serve as nails. Studs are available in straight or bent pieces, hooks, or eye bolts. 310 processing selection. Figure 3.2 the selection guide of the welding of the process discussed with the chapter with the table is based on the particular application encountered with the field welding. Alright, here's the chart of the summary welding process application. Conditions, materials commonly welded: steel, cast iron, nickel alloy, stainless steel. Your free flight pulse current with all acceptable brass, cast iron, wrought iron, lead, tungsten. Your flux cord steel, arc, gas, tungsten, arc welding, all gas, TIG, some stainless steel, submerged arc welding, and stainless steel and stainless steel, exothermic steel, cast iron, electrical, copper, steel, titanium, and aluminum. Your conditional normal use manual shield, SHAH welding. Semi-automatic for all, free flight per bolts, short current flux core, milling, auto arc, gas tungsten arc welding, shield semi-auto and shielded arc welding, and manual exothermic welding and all welding position, all shield, SHW type welding, free flat horizontal position for free flight, and all pulse current, short current flux core, and arc, gas tungsten arc welding, and flat horizontal fillets and exothermic flat and all. Base metals thickness all 1/4 of an inch and up at free flight and all for the pulse current and short current 1/4 inch and up for flux core, all for the gas tungsten welding 1/4 inch up for the submerged arc welding and all for the exothermic studs. Chapter 4 Welding Stainless Steel.